Hey everyone, this is Understanding VXLAN using BGP EVPN Video 7. Well, this is where we left off. We're going to explain these commands here. Let me do a show run to be able to see them a little better. Okay. So these three commands. What are those commands doing? They're acting as a filter to tell BGP exactly which local subnet should be advertised to the rest of the VXLAN fabric as EVPN route type 5. You'll see those type 5s when we do the show commands near the end. So the prefix list. So this is the name of the prefix list. It's PL tenant subnet. So think of this like your shopping list. Currently it only has 3 items. Now let's look at the route map, RM EVPN export permit 10. So think of this as like the manager that looks at the list and it says if a route matches the prefix list, I'll permit it to pass. Later on under BGP, we're going to have VRF tenant-A, and it's going to say redistribute direct route map RM EVPN export, and you'll see that a little bit later. I might have said something there that might not have been right, but we will go over that. Okay, let's go over the next command, VRF context tenant-A. So here we're moving into the VRF, right? VRF stands for virtual routing and forwarding. This is where we move from just bridging layer 2 to actual routing layer 3 within the fabric. So in the networking world, a VRF is like a virtual router. And just like a single physical switch can have multiple virtual switches or VLANs, a single physical router can have multiple virtual routers or VRFs. So one reason for VRFs would be isolation. So imagine you have 2 departments, accounting and guest. You want them to use the same physical router, but you never want their traffic to touch. By putting them in different VRFs, they have completely separate routing tables. Even if they use the same IP address, they will never see each other. In this lab, tenant A is a container for all the subnets we've been talking about, VLAN 10, 20, and 30. It acts as the parent for those networks. So let's imagine a large office building. The VRF context tenant A is like renting out the 5th floor to a specific company. They have their own hallways, they have their own mailroom, but people on the 4th floor or any other floor can't just walk into their offices. Even though everyone's in the same building, which would be the router, tenant A has its own private world. Now let's talk about the command underneath the VRF context, tenant-A, the command VNI 50,000. Now, knowing that VRF is layer 3, and we know that everything underneath here should be layer 3, right? Or should be. VNI 50,000. So we're looking at layer 3 VNI now. Up until now, we've used VNIs like 10010 and 10020 to move traffic within the same VLAN. VNI 50,000 is different. It is a transit VNI that allows different subnets to talk to each other across the fabric. This is what's going to allow VLAN 10 to talk to VLAN 20 and so forth. VNI 50,000 is a non-data carrying VNI used specifically for routing. So when we say non-data carrying, what do we mean? What is actually meant is that it doesn't belong to any specific group of users or a specific VLAN. In a VLAN fabric, when you want to send a packet from VLAN 10 on VTEP 1 to VLAN 20 on VTEP 2, the switch doesn't use the VNI for VLAN 10 or 20 to cross the core. Instead, it wraps the packet in this special VNI 50,000. You can see it as a transit envelope. So if VTEP 1 needs to send a routed packet to VTEP 2, it needs a VNI that represents the VRF, which would be Tenet A, not just a specific VLAN. Again, think of VNIs 10010 and 10020 as the individual rooms in an office suite. Think of VNI 50,000 as the main hallway of the office to get to those. So if you want to move from one room to another within the same building, you just walk through the door. But if you want to go to a room in a different building, then you'd have to use a VNI 50,000. Basically meaning VLAN 10 can talk to VLAN 10, VLAN 20 can talk to VLAN 20, but if VLAN 10 wants to talk to VLAN 20, then it would use the VNI 50,000. Next command is going to be the RD auto. RD auto under the VRF context tenet A. Alright, so what is RD auto? So RD stands for route distinguisher. When you have multiple tenants like tenet A and tenet B and so on, they might use the exact same IP address. Without a route distinguisher, if both tenants have a device at 10.10.0.50, the spine, remember we call that the air traffic controller, would get confused. It wouldn't know which 10.10.0.50 you're talking about. So what is RD auto? The route distinguisher is a 64-bit prefix that gets prepended, which means at the front, if an IP address to make it of an IP address to make it globally unique across your fabric. If you wanted to, you could be specific and tell it what to do, but it's better if you put auto on there. So instead of you manually coming up with a number like 6500, which would be the BGPAS colon 50,000, remember the 50,000 is the VNI, the layer 3 VNI. The auto keyword tells the switch, take my BGP router ID and combine it with a unique number for this VRF to create a unique ID automatically. Just makes it easier. So it turns a standard IP route into a EVPN route. So let's say, this is just an example, let's say it changes 10.10.0.50, which is Ubuntu Desktop 1, into something like 11.11.11.11, which is the loopback of VTEP 1, colon 10.10.0.50, which is Ubuntu Desktop 1. The whole thing would be, the number would be 11.11.11.11, colon 10.10.0.50. Now, even if another VTEP has a different tenet B, the spine can tell them apart because their tags, the route distinguishers, are different. In a large fabric with hundreds of switches, manually assigning RDs or route distinguishers is a nightmare and leads to typos. The auto ensures every switch uses a predictable, unique value based on its own identity. So here's another way of explaining it. Think of the IP address, the 10.10.0.50, as a phone extension, like extension 50. If you just tell a receptionist, connect me to extension 50, they won't know if you mean the extension 50 in the accounting department or extension 50 in sales. Route Distinguisher Auto tells the receptionist, whenever I talk to an extension, or whenever I talk about an extension, I'll automatically add my department ID to the front so you know exactly which room I'm talking about. Alright, next command is going to be the address family IPv4 unicast. So now we're entering the submenu of the VRF where the routing brain starts to do its heavy lifting. In Cisco speak, an address family is simply a specific language or type of traffic. Inside a VRF, which we are because we did the VRF context tenet A would be the name of course, this command tells the switch, I want you to prepare a routing table specifically for standard IPv4 addresses for this tenet. Even though the hallway, which is VNI 50,000, and the name tag, which is the route distinguisher or RD, even though they're set up, the switch needs to be told which kind of data it's supposed to be routing. By entering this address family, you are opening the door to tell the switch how to handle IP traffic for your Ubuntu desktops. Without this, the VRF is just a hollow container. This command allows the VRF to understand things like 10.10.0.0/24. It sets the stage for BGP. This is a specific place where you will later tell BGP to export these routes to the rest of the fabric. Just like BGP itself, a VRF can speak multiple languages. You could also have an address family IPv6 unicast here if you wanted to support newer IP addresses. This command keeps the IPv4, which are the instructions, neatly organized in their own folder. Alright, now let's go over the route target, both auto EVPN. So we already went over the route distinguisher, now let's go over the route target. This is arguably the most critical instruction in the entire VXLAN configuration. If the route distinguisher is a name tag, then the route target is the import-export license. In a BGP EVPN fabric, just because a spine knows about a route doesn't mean it will automatically give it to every VTEP. The route target is a set of instructions that tells the switch which routes it is allowed to export or send out, and which ones it should import or take in. Alright, now the both. This tells the switch to use the same number for both importing and exporting. The auto. This tells the switch to generate the number automatically, usually by combining your BGP AS number and the VNI like we talked about before. So 6500:50,000. The EVPN. This tells the switch to apply these rules specifically to the EVPN control plane. Without route targets, the instructions BGP routes would just sit on the spine and never be used by the VTEPs. It acts as a lock and key. VTEP 1 exports a route with the key 6500:50,000. VTEP 2 sees that route and checks its locks. If VTEP 2 is configured to import 65,000 or 6500, it is 65,000. So 65,000, which is the BGP AS :50,000, it opens the instructions and adds it to its own routing table. So let's think about this. This is how we keep tenant A from talking to tenant B. So how do we do that? Tenant A uses a route target as 65,000:50,000. Tenant B uses a route target as 65,000:60,000. Even though the spine has both sets of instructions, VTEP 1 will only import the ones that match its own tenant's key, right? So the tenant key on VTEP 1 is the one that ends at 50,000, and tenant B is 60,000. So the 50,000 will not talk to the 60,000. That's what it's trying to say. Alright, in the next video we will start configuring the interface VLANs and how that corresponds with VXLAN. I'll see you in the next one.